Hello students, welcome to today's class on trigonometric ratios. Trigonometric ratios are very important as well as interesting topic to learn. And there are many real life, real world applications based on trigonometry. Right? My name is Avinash and I have done my graduation from IIT Kharagpur. So let us start today's class. In the previous class, when we are discussing what is a trigonometry, we discussed that it is a measure of angles in triangles, or it is a ratios of sides. Okay, trigonometry is always about tri. Tri means three. Gono means angles. Metry means measure. Right? It is some subject which is related to three angles. Three angles means triangle. So this topic is all about finding different relations in triangle. Maybe it is with respect to angles, it may be with respect to sides. But in today's class, we are going to discuss a trigonometric ratios. Ratios means we are trying to find the ratio between the sides of triangle. Which type of triangle we are considering? We are considering a right angle triangle. Okay, so let us consider a right angle triangle. Okay, you can see here. Here, exact vertical line and horizontal line represents this angle is 90 degrees. Represent this angle is 90 degrees, correct? It is a right angle triangle. Let us name them. Okay, so if you name this as A, B, C, this triangle is a right angle triangle with right angled at B. Right angled at B. And you know, always in a triangle, the largest side or the side which is opposite to the right angle, the side which is opposite to the right angle is called hypotenuse. And now, to define the other two sides, we take a reference. Here, we take the reference of this angle which is theta. Okay, so this symbol is called theta. This is a standard symbol to represent an angle. You can represent with any variable. You can represent with x, y, a, b, p, q, whatever it is. But standard form we use theta or else x in majority of the cases. So what is that? With respect to theta, whichever side is opposite to that theta, opposite is called opposite side. So AB is called the opposite side. It is opposite with respect to the angle theta. And now, as the side BC is just adjacent to this angle, right? These two are adjacent side by side. But we already named this angle, this side as hypotenuse. So this side BC, we will name it as adjacent side. Again, I am telling you, opposite or adjacent are not always fixed. They change with respect to the angle of reference. Here, angle is theta here. In case if you consider some other angle here, so with respect to this A, this becomes opposite and this becomes adjacent. So that depends on the angle which we are considering. So now we are going to find, or we are going to discuss about the ratios. Ratios of what? Is it ratios of angles? No. We are going to discuss ratios of sides. You know what is ratio, right? Okay, the ratio of 1 and 2, if I tell you the ratio of 1 and 2, you write it as 1:2 or 1/2. That is the ratio. Correct? The same way now we are going to discuss about the ratio of sides. What are the sides? Opposite, adjacent, hypotenuse. So we have three sides. So let us try to see what are all the possible different ratios with the sides. Okay. The very first one will be opposite side by hypotenuse. Opposite by hypotenuse. The next one, opposite by hypotenuse is done. Now adjacent by hypotenuse. The next one is adjacent by hypotenuse. Now without hypotenuse, we'll consider only these two, that is opposite by adjacent. Opposite side by adjacent side. Okay, so these are the three main trigonometric functions. And when I say these are the three main trigonometric functions, all the other three which we are going to write it now, they're exactly the reciprocal of these three ratios. Reciprocal means upside down. Numerator will be transformed to denominator, denominator will be written in the numerator. That means we have opposite by hypotenuse, so now we'll write hypotenuse by opposite. Hypotenuse by opposite, that is one ratio. Okay, here hypotenuse by adjacent side, so that is one more ratio. And here adjacent by opposite, so that is one more ratio. In total 1, 2, 3 and all the three reciprocals 4, 5, 6. Total we have 6 different ratios with respect to the sides. We totally have 6 different ratios, or we say 6 different functions. Every ratio can be considered as a function in this trigonometry. Okay, so let us try to discuss each and every function individually. The first one we're going to discuss is sine. Sine of angle, or we represent in short as a sine theta. Don't say sin theta, okay, it is called sine, S-I-N-E, but in short we write S-I-N, sine theta. So what is sine theta? When we consider a right angle triangle, let us name it as ABC. ABC. The ratio of opposite side to hypotenuse. Opposite side by hypotenuse, it is called sine theta. Opposite by hypotenuse. What is opposite? AB. AB by what is hypotenuse? AC. So that is the ratio sine theta. We also say it is trigonometric function. Trigonometric ratio or trigonometric function. Okay. The first one we have discussed is a sine theta. The next one we're going to discuss is with respect to adjacent and hypotenuse. Adjacent and hypotenuse, which is called cosine of angle or cos theta. We say it is a cos theta. Cos theta is adjacent by hypotenuse. If this is A, this is B and this is C, adjacent by hypotenuse BC by AC. BC by AC, adjacent will be BC by hypotenuse is AC. So that is the ratio cos theta. What is sine theta, which we just discussed before this one? Sine theta is equal to opposite AB by hypotenuse AC. AB by AC, and cos theta is BC by AC. Cos theta is adjacent by hypotenuse. Right? Now, as we discussed two ratios with respect to hypotenuse in the base, in the denominator, now let us try to discuss one more ratio without hypotenuse. Without hypotenuse, that means only two ratios are left, only two sides are left, opposite and adjacent. So what is opposite side by adjacent side? It is called tangent, or in short we write it as tan theta. Tan theta is opposite by adjacent. Opposite by adjacent, that means AB by BC. Okay, AB opposite side is AB by adjacent side is BC. So that is a value of tan theta. Tan theta is equal to AB by BC. So now, as we have discussed three important functions, I told you in the earlier slide only, the other three functions will be the reciprocal of all these three functions. Reciprocal means upside down. What is the first we discussed? Sine theta. What is sine theta? Sine theta, which we discussed in the first slide, first function, is opposite by hypotenuse. Opposite by hypotenuse. So now we will tell about the reciprocal hypotenuse by opposite side. Hypotenuse by opposite side, which is called cosecant theta. Hypotenuse by opposite. Okay, so that is hypotenuse, that is cosecant theta. So what is hypotenuse? What is opposite side here? Hypotenuse is AC. cosecant theta, okay, hypotenuse is AC, by opposite side is AB. What is sin theta, if you can remember? Sin theta, which we discussed long back, is opposite side AB by hypotenuse AC. Hypotenuse AC, correct? Is there any relation between these two? Yes, why not? I said they are reciprocal to each other. If you multiply cosecant and sin theta, if you multiply these two as a reciprocal, both get cancelled and you'll get the value 1. What is the reciprocal of number 3? 1 by 3. So what is the multiplication of 3 into 1 by 3? 3 and 3 gets cancelled, you'll get the value 1, correct? Any number into its reciprocal will give you the answer as 1. The same way, okay, we have sin theta into cosecant theta is equal to 1. Sin theta into cosecant theta is equal to 1. So cosecant we have discussed with hypotenuse by opposite. The next one we are going to discuss hypotenuse by adjacent. Hypotenuse by adjacent. So what is that? So that is called secant of an angle or sec theta. Okay, we read it as completely secant theta, but in short, to write in short, we write SEC theta. Okay, so what is that? What is cos, if you can remember? Cos theta is adjacent by hypotenuse. Cos theta is equal to adjacent by hypotenuse. So now the point is exact reciprocal of that will give you sin theta. Exact reciprocal of that hypotenuse by adjacent side. Okay, so if this is ABC, so secant theta is equal to hypotenuse AC by adjacent side BC. By adjacent side BC. Secant theta is equal to AC by BC, correct? We discussed sine, the reciprocal cosecant. Cos, reciprocal secant. Tan, the reciprocal will be cot. Tan theta, tangent reciprocal will be cotangent, or in short, we write it as cot. What is tan theta, remember? Tan theta is opposite side by adjacent. So cot theta will be the reciprocal or the reverse, adjacent by opposite. Adjacent by opposite. So what is adjacent? Okay, if this is ABC, what is adjacent? Adjacent is BC. By opposite is AB. So that is the value of cot theta. Cot theta. We already discussed what is tan theta. What is tan theta? Tan theta is equal opposite AB by adjacent BC. So again I'm saying you, even these two are reciprocal to each other. That means cot theta into tan theta will always give you the value 1. Cot theta into tan theta will give you the value 1. The same way before case also. Secant into cos, that will also give you 1. So these are the different trigonometric ratios we are having. Opposite, adjacent, hypotenuse. We have 3 sides. Opposite by adjacent, adjacent by hypotenuse, hypotenuse by opposite. 3 ratios. Opposite by hypotenuse, hypotenuse by adjacent, adjacent by opposite. We have 3 more. The total, we have 6 different trigonometric ratios, or we say 6 different trigonometric functions. Correct? So now let us try to understand more about these functions and how to find, if one ratio is given, how to find all the other ratios. Everything is interlinked. But before that, let us try to understand one small concept, that is Pythagoras theorem. You might have already learned in your lower classes, but once again, let us have a small recap of what is Pythagoras theorem in a right angle triangle. In a right angle triangle, what is a Pythagoras theorem? Pythagoras theorem always states that the longest side, that is hypotenuse, or the side opposite to that, opposite right angle is hypotenuse. Hypotenuse square, okay, so if I write this as ABC, hypotenuse square is equal to the sum of the squares of other two sides. Sum of, that means two elements will be there. Squares of other two sides. Squares of other two sides. So AB square plus BC square. Okay, AB square plus BC square. Instead of writing like this, okay, instead of AB and BC, we'll again come back to this. Instead of writing AB and BC, we'll take about opposite and adjacent. Okay, opposite side whole square plus adjacent side whole square. So what is hypotenuse? AC square. AC square is equal to opposite AB square plus adjacent BC square. So why this theorem, Pythagoras theorem, is very important is, if you know any two sides of a right angle triangle, you can easily find the third side. Using this relation, hypotenuse square is equal to opposite square plus adjacent square. Okay, what I told, if you have two sides, you can simply find the third side using this relation, Pythagoras theorem. Let us try to take one question based on this, and let us try to apply Pythagoras theorem to find the unknown values, and then also we'll discuss all the trigonometric functions in the same problem. So let us take one question here. Given sine theta is equal to 3 by 5. If sine theta is equal to 3 by 5, then find the value of all other trigonometric functions. All other trigonometric functions. The first point here is, what is sine theta? I told you many times from the first we are discussing. Sine theta is opposite side by hypotenuse. Sine theta, for this theta, opposite by hypotenuse. Okay, so this is ABC. Sine theta is equal to AB by AC. Sine theta is equal to AB by AC. And this value is given as a 3 by 5. As this is a ratio, okay, as is a ratio, we can consider AB length as 3 units, 3 centimeters or 3 meters, whatever it is, and hypotenuse AC as 5 units. You may ask me one question here. Sir, why we are taking directly 3? Why can't we take 6 and 10? Even 6 by 10 is also equal to 3 by 5. Why can't we take 6 and 10? You can take. You can take any length, but this ratio should be followed. Till the point you're following this ratio, you can take any value. It's 3 or 6 or 9 or 10, 15, whatever the value is. This ratio should be maintained. So to avoid all those confusions, directly take opposite side as 3 and hypotenuse as 5. Correct? Now tell me, how to find adjacent side? Because we don't have adjacent side. Let me take adjacent side as x units. This is 3, this is 5, this is unknown. Just now told you about a Pythagoras theorem, which is useful to find the missing side if you have two sides in a right angle triangle. If you have two sides, here hypotenuse and opposite side is there, but we don't know what is adjacent side, so we'll try to use a Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square, that is 5 square, is equal to the sum of other two side squares. So 3 square plus this is x square. So 5 square is 25 is equal to 3 square is 9 plus x square. So 25 minus 9 is equal to x square. The 9 here will be transformed to the other side, becomes 25 minus 9. What is 25 minus 9? 16. So I can say x square is equal to 16. So what is x equal to? So x is equal to root over 16, which is a 4. Okay, we can also get a minus 4, but when we are discussing about the length of the side, we don't take negative values, we take only positive values. Okay, so x is equal to 4. So now as we have all the sides, it is very easy to write all the ratios. 3, 4 and 5. So once again, let us try to clear all this and go for the ratios. Okay, so opposite side is 3, this is given 5 and this value is 4. That is what we are having, correct? So what is a sine theta? It's already given 3 by 5. So as sine is already there, we'll write for cos theta. What is cos? Adjacent by hypotenuse, 4 by 5. Adjacent by hypotenuse, 4 by 5. 4 by 5. Okay. What is a tan theta? Tan theta is opposite by adjacent. Opposite by adjacent, 3 by 4. 3 by 4. Okay. Sine is there. Cos, tan. Reciprocal of sine becomes cosecant. Reciprocal, that means 3 by 5 will turn upside down, will give you 5 by 3. Cos theta reciprocal will be secant theta. So 4 by 5 will become 5 by 4. And it's tan, the reciprocal of that will give you cot theta. Cot is 4 by 3. Cot theta is 4 by 3. So that is how you can find all the trigonometric functions. Very simple, correct? It's very simple. The point, if you get all the 3 sides using Pythagoras theorem, it is enough to get all the ratios because it is just the ratio between the sides. All these functions are nothing but the ratios between the sides, but the only mistake you do is you confuse with one ratio to the other. Instead of writing cos, you may go for tan and you say tan it is 4 by 5, cos it has 3 by 4. The only point is you get confused. Concept is very simple. Concept is very simple. The only point is you get confused among all the 6 different ratios, which should not happen. Right. So one more question for your understanding. Can a triangle be possible with sine theta is equal to 5 by 4? In a triangle, it was given sine theta as 5 by 4. So now the question is, can such type of triangle be really possible? Can such type of triangle where you have sine theta as 5 by 4 really possible? If it is possible, it is okay. If it is not possible, just understand why it is not possible and what is the meaning or what is the actual concept behind this, why sine theta cannot be 5 by 4. Right? So this one we are going to cover in the next video. What is sine theta? Sine theta is actually opposite by hypotenuse. Opposite side by hypotenuse. Okay, the rest everything I'm leaving for your understanding, so please try to solve and see whether this is possible or not. Okay, so we have discussed a very beautiful concept on trigonometric, that is a trigonometric ratios. Trigonometry, again I'm saying, it is a measure of 3 angles. That means it is a measure of triangles. In triangles, especially in the right angle triangle, all the different ratios will give you all the different functions, trigonometric functions or trigonometric ratios. I hope you understood this video. In the next video, we're going to discuss more about trigonometry. Thank you so much.
Hello everyone. So now we'll be discussing about laws of reflection. You might have already learned about this, so we'll be going into the basics. We'll be revising all the topics that we need. Okay, so my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's quickly go into the class. Alright, so whenever I talk about reflection, so first of all look at this. If you have any object let's say, okay, and if light falls on this object, then what can happen to this light? So it could be this air, and let's say this is made up of any object, right? So what can happen? What can happen will depend on the material, as we know. Yes or no? So there are 2 things that can happen. One, the light can actually go back, and the other, the light can enter inside. Okay, these two things can happen. What's happening? The light is again going back into air, first case, and or the second case. This is the first case, this is the second case. First case, the light is going back. The second case, light goes into the medium, goes into the material. So these are two different phenomena. In the first case, it is called as reflection, and in the second case, it is called as refraction. Okay. So for now, we'll be learning about reflection. Then later on, we will also go into refraction. Okay. So when will the light be reflected? When will reflection take place? Reflection will take place when the object is opaque. What is that? When you have an opaque material, opaque object, light will not pass through it. Opaque objects do not allow light to pass through them. That means light will be reflected. Light will bounce back. So that is reflection. Now, when we discuss about laws of reflection, what do they do? What do laws of reflection do? What they do is they predict, or they help us in predicting the direction of the reflected ray. How will it be? See, going back into the medium, this is also going back into the medium. This is also going back into the medium. This is also going back into the medium. All of them. But in which direction will it exactly go back into the medium? In which direction will the light be reflected back exactly? That we will understand through what? That we'll understand through the laws of reflection. Okay. So let's go into that. Let's first look at a simple animation, how it is going to be. So here, if this is a surface, there is a light incident on the surface. A light incident on the surface, what do we call it? We call it as incident ray. We call it as incident ray. Now, how do we predict the reflected ray? For that, one line that we need is what? Normal. That is, at this point is, we call it as point of incidence. What do we call it as? Point of incidence. That is the point where the incident ray is incident on the surface. The point where the incident ray touches the surface. That is a point of incidence. At the point of incidence, we draw a perpendicular line. So we call it as normal. Now what is that? It's just a perpendicular line. It is not a ray. It is not a light ray. It is a perpendicular line drawn to the surface. Perpendicular. That is the angle between the normal and the surface will be how much? 90 degrees. Perpendicular. Okay. And then after that, the reflected ray will be something like this. Clear? What do we call it as? Reflected ray. Now, to understand or to identify incident and the reflected rays, look at the arrows. Look at this arrow. What does this arrow tell us? This arrow tells that this ray is going towards the surface. See the point? It is going towards the surface. Towards. It is incident. That is the reason why it is called incident ray. If you look at this arrow, the point is here. It is going away from the surface. It is reflected ray. That is the reason why arrows are very important. You have to show the arrows. And then this angle here. This particular angle. What is this angle called as? It is called as angle of incidence. Now be very specific, be very peculiar, or be very particular here about this. That is, angle of incidence is angle between incident ray and the normal. That's it. That's how you define angle of incidence. Angle between incident ray and the normal is the angle of incidence. Generally we use small letter I as the symbol for angle of incidence. And then you have angle of reflection. What is that? This R, small r. It is the angle between the normal and the reflected ray. That's it, see? Angle between normal and the reflected ray. Remember the definitions clearly. Understood? Okay, now let's continue. So the two laws are here. What is the first law? The first law will say that the incident ray, the normal and the reflected ray, all three of them lie on the same plane at the point of incidence. So their main point here for this particular law is they lie on the same plane. So for example here, look at this. If this is the incident ray, arrow shows it. This is the normal. Now these two, both the incident ray and the normal, are on the screen. They are on the screen. That means the reflected ray will also be on this screen. It will not be like the ray will not be outside of the screen, like in this way. No. In this way, no. In this way, no. It will be on the screen, on the same plane, lie on the same plane. Okay, at the point of incidence. And the second one is very simple. Angle of reflection is equal to angle of incidence. Right, this shows us that they are on the same plane, and this is what angle of incidence I. What is this angle of reflection R? I will be equal to R. That means, for example, if I is 27 degrees, R will be 27 degrees. If I is 52 degrees, R also will be 52 degrees. Right? Both of their angles will be equal. That's what it says. So, very important laws. They help us in predicting the direction of reflected ray. Clear? Simple enough? Okay, let's continue. So, we have a very simple question here. What are the angles of incidence and reflection in the following case? What is the case here? You have the surface and the light is incident in this way, in this particular direction. Look at the arrow, look at the direction, and you tell me here what is the angle of incidence and the angle of reflection. First, we'll go with angle of incidence. What is the angle of incidence? Two options, 0 degrees, 90 degrees. What is that going to be? I don't think. I'll give you some time. I'll give you 30 seconds of time. So please think and then answer. What is that going to be? What will the angle of incidence be, or the angle of reflection for that matter? Angle of incidence. What will the angle of incidence be in this case? Yeah? 5 seconds more. 3, 2, 1. And the time is up. And what is the correct answer? The correct answer is option A. The correct answer is option A. And here, just a minute. It should be reflection. L. Okay? Reflection. So the correct answer is what? The correct answer, just a minute. The correct answer is 0 degrees. Now you might ask me, sir, how 0? Why 0 degrees? I'll explain. Look at this. If this is a surface, this is the incident ray. Now what is angle of incidence? Angle of incidence I is the angle between what? Angle between incident ray and what? And normal. So how is the normal here? Yeah. If I use another ink, the normal is exactly like this. Yes or no? The normal is along the ray itself. That means if I separate these two, the ray and the normal, the incident ray will be something like this and the normal is like this. Look at them, are they parallel? The incident ray and the normal, are they parallel? Yes, they are parallel. And if they are parallel, the angle between them will be 0 degrees. If two lines are parallel, the angle between them is how much? 0 degrees. So here what is the angle? 0. The angle between incident ray and the normal is 0 degrees. So angle of incidence is 0 degrees. This is a special case. And what do we call this case as? We call it as normal incidence. So in the case of normal incidence, angle of incidence is 0 degrees. We know that R is equal to I. So R also will be 0 degrees. So for reflected ray, all that you have to do is just show an arrow up. That is, it is incident and then it will reflect back along the same path. It will retrace back along the same path. It will retrace the path. Clear? So which case is this? Normal incidence, and both the angle of incidence and the angle of reflection, both of them will be 0 degrees. Clear? Okay, wonderful. Let's continue. Now we'll go into regular and irregular reflection. What is that? Look at this. Here this is regular reflection and this is irregular. What difference can we notice? Here in regular reflection, incident rays are parallel in both the cases. Or I can say incident beam, I beam. I beam will mean incident beam is a parallel beam. Okay, in both the cases. Look at the green rays. These are what? The green color rays. They are incident beam. Here also green color rays are parallel. Here also they are parallel. But look at the reflected beam. In the case of regular reflection, the reflected beam is parallel, but in the case of irregular reflection, the reflected rays are not parallel. Reflected rays are not parallel. Okay, that is a basic difference. And the image will show you one more important point. That is, here you have a smooth surface. In case of regular reflection, we have smooth surface. In case of irregular reflection, you have a rough surface or an irregular surface. Best example for smooth and rough surfaces, or for regular reflection and irregular reflection. In the case of a plane mirror, mirror is smooth, surface of mirror is smooth. So in the case of a plane mirror, we have regular reflection. But in the walls, wall is rough. So in the wall you have irregular reflection. Clear? So regular and irregular reflection. And where do we get the images? Regular reflection, you get images. Smooth surfaces, we get images. That's why we cannot see our images in walls. Walls are rough. Okay? Okay, that's good. That's good. Let's continue. Now again, image formation by a plane mirror. So if we take a plane mirror, normal everyday mirror, everyday looking mirror, okay? So that is plane. So here what happens if I take this point as the object? That point I am taking as what? The object. Now the rays will always start from an object. Okay, so let's say we take one ray starting from an object. Now this ray from the object is incident on the surface. Here we are taking surface as plane mirror. So it is plane mirror. Then what happens? Reflection happens. How? You draw the normal and this is the reflected ray. Clear? Then this one ray. To get an image, always remember this, to get an image we need a minimum of two rays. Two rays. So I'll take another ray. Another ray starting from the object. Look at the arrows. Arrows are very important. These two are incident rays. Then you draw the normal again. We need loss of reflection. And it is reflected ray. Now, if there is any observer here, now for that observer, look at this, these two rays, these two rays, when they are extended back, they meet at this point. Yes or no? So for the observer here, the observer will feel that there is something here from where the two rays are coming. And what is that something? That is the image. That is the image. Clear? So you have the object, the rays, reflected rays, and when you extend the reflected rays back, you get the image. Clear? You get the image. So here, that's how we get image formed by a plane mirror, ray diagram of it. Okay. Now if you look at this, there are some properties here. Okay, we'll be going into the properties of the image formed one by one. Don't worry. Okay, let's continue. So before that, let's go into something called as real and virtual image. What are they? Now here in this particular case, this is where the image is formed. But at the image, are the rays actually meeting? Are the rays actually meeting? No. These are the rays. They are not meeting. When you extend them back, they appear to meet. So these two reflected rays, they appear to meet. They are not actually meeting, but they appear to meet. So these type of images are called as virtual images. Okay. So if you talk about a real image, they can be obtained on a screen as rays of light actually meet. The best example, projector screen. If you use a projector on the wall or any cloth, white cloth, you can project it. So that white cloth or the wall is a screen, and on the screen images can be obtained of what? Of real images. Images can be obtained on a screen and rays of light actually meet. But when you talk about virtual image, what happens? Rays of light do not actually meet. Rays of light do not actually meet. So what happens is our brain does the magic. Our brain perceives the light to be coming from a point behind the mirror. So these images are formed behind the mirror and cannot be obtained on screens. Very simple. Here, main point, rays of light do not actually meet. Here, look at this. Wherever the image is formed, is there anything there? Nothing is there. Then why do we see something? Why does the observer see something? It has to do with the brain. The brain does it. Okay? Okay. So real image and virtual image, basic difference. Real image can be obtained on a screen. Virtual image cannot be obtained on a screen. Real image, rays actually meet. Virtual image, rays appear to meet. Okay? Okay, that's good. Right, again another question for us. So the image formed by a plane mirror is what? Real or virtual? The image formed by a plane mirror. Do the rays actually meet or not? You have to think in terms of that. And the answer is what? The answer is, it is virtual. The image formed by a plane mirror is virtual. Rays do not actually meet. See, one property you yourself answered. That's wonderful. One property you yourself answered it. Okay? Okay. So these are some characteristics of images formed. One is, whenever you look into a mirror, okay, even if you have a mirror now itself you can look into it and understand all these properties. One, it is laterally inverted, very important. What does laterally inverted mean? Now, if you are standing in front of a mirror, okay, let's say you are standing in front of a mirror, and if I raise my right hand, what will my image do? It will raise its left hand. Or else, better example, now while eating, okay, so let's say if you are a right-handed person, okay, you are eating with your right hand. So you are eating with right hand, and when you look at your image in the mirror, you are eating and looking at your image in the mirror, what happens? Your image will appear to be left-handed. Your image will appear to eat with left hand. And if you are a left-handed person, then if you're eating with the left hand, your image will appear to eat with right hand. That is, left becomes right, right becomes left. This inversion, this change in left and right is called as lateral inversion. Or we say the images are laterally inverted. You can look at another example here. This boy is raising his right hand, but the image is raising its left hand. So right becomes left, left becomes right, that is laterally inverted. Second, the image is virtual. We understood it cannot be obtained on a screen. The rays do not actually meet. Now it is erect or upright. What does it mean? See here, the head is up. The head of the boy is upwards. The head of the image is also up. It is not upside down. Right? So it is not inverted. It is erect. It is upright. And the size of the image is same as size of the object. In a plane mirror, what happens? The size of image is is same as the size of object. One more property is that if the distance, if this is you and if this is your image, the distance between the object or you and the mirror, let's say here for example it is 20 centimeter, then the distance of the image from the mirror will also be 20 centimeter. That is equal distance. We can say distance between object and mirror is equal to distance between image and mirror. Distance between object and mirror is equal to distance between image and mirror. So some very important points that we have learned. Some important properties of the images formed by which mirror? Plane mirror. By which mirror? Plane mirror. Okay? Okay, let's continue. So one interesting question for us. Which of the following letters will look the same in a plane mirror? Now the letters are not A, B, C, D. What are the letters? The letters that we are talking about here are P, B, A, Q. Okay? So let's look at them. Let me explain that. So let's say this is the mirror. When I take P, now if I do lateral inversion, left becomes right, right becomes left. So here it is in this way. Yes or no? So this is different. They are facing each other. So are they the same? They are not the same. Then we'll go with B. B will be something like this. Are they same? Not same. Then I'll go with A. Now A will be the same. I'll go with Q. Now here Q will be something like this. Are they equal? They are not equal. Which is equal? A is equal. So A or option C is the correct answer. Simple. Now how do we tell which is correct and which is wrong, which is laterally inverted? All of them are laterally inverted, but here we cannot notice it. Why? Because when I draw the letter A, see, I'll just draw a line in between. Left of this line and right of this line are the same. Left and right of A is the same. But if I take P and if I draw a line in between, you can clearly see that the left and the right of the letter are not equal. So the left and right are equal in A. That is why even after lateral inversion, it is the same. Okay, understand that. Clear? Okay, that's good. Now another question for us. What is this? A ray is incident such that it makes an angle of 30 degrees with the surface. What is the angle between the incident and the reflected ray? Now read the question properly. A ray is incident such that it makes an angle of 30 degrees with the surface. That means here if this is a surface, the incident ray is something like this. This angle is given as 30 degrees. With the surface, the angle is given as 30 degrees, and we have to find out what? We have to find out the angle between incident ray and the reflected ray. Let's draw the normal. Now if this is 30 degrees, how much will this angle be? See, normal and the surface, it is 90 degrees. So here the angle of incidence is 90 degrees minus 30 degrees, which is how much? 60 degrees. So the angle of incidence is 60 degrees. We know that R is equal to I. So angle of reflection will also be how much? 60 degrees. So this also is how much? 60 degrees. Now what we need is the angle between incident ray and the reflected ray. And what is that angle here? See, 60 plus 60. That is what? Here it is 60. Here it is 60. So this complete angle will be 60 plus 60, 120 degrees. So the answer is option C. So the clue here is what? With the surface. That is the keyword. With the surface. If you understand that, the rest is very simple. Okay? Okay. So that's it, everyone. That's it for the basics, for the laws of reflection. Okay? Okay. Chalo then. Thank you, everyone. Thanks a lot.